Hello, welcome back to another calculus tax from Dr. Putu Gunawan. Tax is for week 4. Topic is convergent test for series. So basically testing convergent or divergent for a function in the series. Let's start with the question. So here I got a question 1, and we are using integral test for this. I took a question of series from n to 2 to infinite for ln n over square root of n. So basically, if you're using integral test, just integral this function. We got the integral, and then we can now input the boundaries infinite and 2, from 2 to infinite. So infinite for this part, and then 2 for this part, and then we basically subtract them. I try to input this on a calculator. It says undefined, maybe because square root of infinite is infinite, ln infinite is infinite, and it is 4 times infinite. 2 minus 4 into infinite, 2 times infinite minus 4 times infinite. Basically, is it minus infinite? I don't know, but what I got from calculator is it is undefined. So therefore I can get a conclusion: undefined minus a number, it is still undefined. Therefore the integral does not converge, it is divergent. Next, for the number 2 question, this question we are using p-series test. I took a question of series of n from 1 to infinite for 1 over square cubic of n. So for this one, we just need to find this kind of form: n to the power of p. We change square cubic of n to n to the power of 1 over third, basically the same as this, but now we get a form of n to the power of p, and the p is 1 over 3. So if the p is less than 1, so we got it is less than 1, it is divergent. For number 3, direct comparison, we're using direct comparison. So basically compare it with a series that we know that the series is divergent or convergent. For example, this thing is, if we use p series, we got n to the 1 over 2, so n to the half, so half is less than 1, so this is divergent. And I took a question of series of n1 to infinite for cos n plus 2 over square root of n. Basically cos n is basically from range minus 1 n to 1, so minus 1 to 1 from that range. So if we plus 2, we can get minus 1 plus 2 is 1, 1 plus 2 is 3. So now the range is from 1 to 3, and over square root of n. So we know this thing is bigger than this one, because it is same or bigger, because we can get 2 here, we can get 2.5 here. So yeah, so if this is bn, and then this is an. So if we know that an, this one, is bigger than bn, this one, therefore if pn is diverged, thus an is also diverged because pn diverged, like this. Next, for number 4, we gonna use limit comparison. For the limit comparison, also the same. We use series that we know them convergent or divergent. For this example, if we multiply this, we get n over 4. So we want a function, series that can divide this n4 into 1, I guess. Yeah, into 1. So if we got n4, we got nothing 1 here, so compare it with n4, we can get n4 here and n4, and therefore it cancel, so it's become 1. So like this one, an over bn. So this is like usual, an and then bn. This is an, so an over bn, so it is the same as an times 1 over bn. So 1 over bn, we can just 1 over n4, so it's n4 over 1, basically n4, n to the 4. We get this equation, and then we get n4 here and to the 4 here, so we can divide this function into divide each of this value with n4 and to the 4. So n to the 4, for n to the 4 is 1, same as this 1, and then for this it is going to be 4 over n squared, because we cancel this, and then this become n square. So 4 over n square, n to the infinity, so it's just basically 0, because it's 4 over infinite. So we know that limit is 1 is bigger than 0, and we know this thing is convergent because n to the p is 4, p is more than 1, so it is convergent. Therefore it is more than 1, also bn converge, therefore we know it is convergent. Next, for number 5, I'm choosing this question. It is series from, this is actually, and I forgot. So this is a series of n1 and equal to 1 to the infinite for n over n plus 1 times 2 to the power of n minus 1. So for this thing, we're going to use ratio test. So ratio test is basically like this. A n plus 1, this function, plus 1, and then it's also divided by its function, but not plus 1 for the n. So for the n plus 1, we got n plus 1, and then this over n plus 1 plus 1, because this is the n plus 1 form, and then 2 n plus 1 minus 1, and then times 1 over n, 1 over n, so it's basically flip this thing, and then n plus 1 times 2 power of n minus 1 over n. So we can simplify this into n plus 1 times n plus 1 times 2n over 2. Yeah, so this become 2n. If we remove this is 2n, because 2n minus 1 is 2n over 2. And then we get this one, we can simplify this become 2 n plus 2, and then this cancel, so it's 2n times this one, 2n. Can cancel this, and then we can multiply this. N times 2n is 2n squares, plus 2 times 2n is 4n, and then n plus 1 times n plus 1, or is it n plus 1 squared, it is n squared plus 2n plus 1, quadratic equation. So we got n2 here, we got n2. So this is the biggest form. So we're going to divide all of this with n squared. So n squared divided by n squared, it's 1. This is going to become 1. This 0. This also 0. This one 1. This one 0. No. This one is 2 because it's, yeah, this one 2, and then this one is 0 because it's going to be 4 over n to the infinite. So 4 over infinite, it's 0. This is 0. So 1 over 2, it's 0.5. We know that 0.5 is less than 1, therefore we get this requirement right. So it is convergent. For the last number, it is a root test. For root test, it's basically taking this equation, this function, and we take the square root of this equation, the not the square root, but the root to the n, and n is going to infinity, like this. And we need and this is the condition, if it's convergent and if it's divergent. So let's start. So we take root of n going to infinite. Basically, if we make it to the power form, it's going to be an, this an, to the power of 1 over n. And then basically, if we got this 2n plus 1, we can change this equation into a e to the power of form. So 1 over n become this. So the learn form 1 over n times ln this, and then over e to the same 1 over n, then but in the denominator we're going to use this one, 5n plus 1. So if we actually take input the n to the infinite, we got infinite 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 over infinite. We can't have that, therefore we're going to apply L'Hopital's rule. We're going to apply L'Hopital's rule. So this form become this form. Basically taking a derivative of this one, and then it's become like this, taking a derivative. So d over dn for this one, d over dn of e 1 over n times ln 2n plus 1 to the power of n plus 1. We got this one. Actually, we can simplify this like this. So ln 2, we got this is ln 2 squared. Yeah, ln 2 squared, and we can take one of them, and then we can cancel these two. Therefore, it's become e to the power of ln 2. And also for the 5, the same. Cancel this, we got e to the power of 5. This form we can just take out the ln and then leave 2 and 5. So we got lim n to the infinite 2 over 5. So there is no more n, so it's 2 over 5. 2 over 5 is 0 0.4. 0 0.4. We know 0 0.4 is less than 1. Therefore, we got this requirement Correct. Therefore, it is convergent. That's basically all the question. See you next time for another calculus text. Thank you.